Engage in international activities at Nexco East and Japan International Cooperation Agency, including surveys and studies of highways in India such as Mumbai Trans Harbour Link, Mahatma Gandhi Bridge, Sharidi Ghat Bypass, etc. I welcome you, sir. Take out the mic.
Okay, everyone. Namaste. Uh, Thank you very much. So, आपसे मिलकर खुशी हुई. Thank you. So, मेरा नाम देंचरो यामादा है. So, मैं जापानी हूँ. So, आज मैं mountainous highways and green highways presentation करता हूँ. Okay, so first of all, I'd like to introduce myself. So, my name is Denichiro Yamada. I'm a civil engineer and currently working in NHAI as JICA expert for highway engineering from this April. And originally, I belong to one of the largest expressway management company in Japan, East Nippon Expressway Company Limited. So I engaged comprehensive expressway management activities such as planning, design, construction, operation, maintenance of expressways, and international activities for over 15 years. So especially, I superintended design and construction of Tokyo Outer Ring Expressway in 3 years. I also have engaged several studies and projects for road and bridge sector in India, so such as Mumbai Trans Harbour Link project or Mahatma Gandhi rehabilitation project. So today, I've divided my presentation in two parts. First, I'd like to explain mountainous highways. In this section, I'll introduce our technical cooperation project. And then, I'm talking about green highways. I'll show you how green space can be created on expressways through Japanese experience. So, let's move to the first topic of my presentation, mountainous highways. First, I'd like to introduce the history of JICA's technical cooperation to India's road and bridge sectors briefly. JICA, Japan International Cooperation Agency, is Japanese government body solely in charge of ODA operation, and it is the world's largest bilateral aid agency. In Indian road sector, JICA has supported 9 important projects under ODA soft loan scheme, amounting over 8,000 crore rupee. Especially in Telangana state, JICA is supporting Hyderabad Outer Ring Road, not only for new construction, but also for introduction of ITS technology. So back to the history. So Japanese technical cooperation was started over 20 years ago. And as you can see in this diagram, since 2007, 2 Japanese experts have been dispatched to MRTH and NHAI. During these 10 years, we developed important guidelines. For example, guidelines for expressways. This is officially approved as a MRTH 239 and published from IRC. So my technical cooperation, the capacity development project on highways in mountainous region, was started just this April. So any output are not made yet. So today, I'd like to introduce the outline of my project, especially what kind of goals and outputs we are aiming. So title of this project is Capacity Development Project on Highways in Mountainous Regions. Project period is 5 years, and we are expected 4 outputs: identification issues and countermeasures on mountainous highways. And also, we summarize them on technical guideline. So I'd like to mention the example to be clear the aim of our project. in consideration with environmental consideration following the theme of this IRC annual session. This photo shows a portal of typical mountainous tunnel in Japan and in India. So please imagine, what is the difference, especially its location? So regarding Indian sample, portal is located valley side. However, in case of Japanese tunnel portal is located hillside. So if we put the tunnel portal on valley side, so as you can see left photo, cut area around the tunnel portal is comparatively larger. And also, so hillside is better location in environmental aspect. And also, construction work can be safe and easy in hillside because water is gathering at the valley area. However, so if we consider the cost effectiveness, valley side is better because tunnel length is short. So this is a just example, but we should find out in our project the most appropriate and suitable tunnel location, means the tunnel planning method in India. And also, we shouldn't forget operation and maintenance. When we consider the operation maintenance of mountainous highways, many factors should be included like this. Especially, I believe tunnel monitoring and operation are the most urgent issues in India because now many tunnel projects are ongoing, including Chennai-Nashri tunnel. For example, the top two photo shows a famous fire accident inside the tunnel in the world. The left one is an example of Europe, and the right one is an example of Japan. So generally speaking, if fire accident is occurred inside tunnel, the situation becomes very serious. Therefore, we should consider what kind of operation is required and how to monitor these tunnels to avoid these situations. So then we will move to my second topic, green highways. First of all, I'd like to show you some photos of expressways, our expressways. So recently, I understand environmental aspects are strong concerns when highways are constructed in India. And NHAI and other agencies start greening of constructing and existing highways. So as you can see in these photos, we have been also created green highways for all seasons, all stretches, and over 60 years. We have big effort and much experience to develop green expressways. So I'd like to give you the awareness and recommendations in order to develop more functional, efficient green highways through Japanese experience. Really? 10 more minutes I have. So I'd like to introduce my company briefly. So my company was established in 2005, and so before establishment of my company, the Japan Highway Public Corporation is only public entity of expressway management from 1956. Therefore, we have 60 years of experience. So we are planting and foresting on roadside slopes of newly constructed and existing expressways. And 99% of foresting on roadside slope is completed until the end of 2015. So as shown in these pictures, you can see green space are created continuously. So to create green expressways, we've developed planting design guidelines. In our guidelines, we expected 3 functions of plants on expressways. These are environmental conservation, the landscape creation, and road safety. So basically, we plant trees on both roadside and median. So when we consider the function of plants on expressways, we've divided its location in these three parts. So we'd like to see the example of each function of plant one by one. So this is environmental conservation and restoration. I think you can imagine this function of planting easily. So the CO2 absorption, the noise, and emission gas is prevented by the roadside forest. And also, the plant has a function of creation of beautiful road landscape. You can also this function easily. And the improvement of road safety and traffic safety is very important function of planting. So plants can control access to highways together with structures like fence. And plants can also guide visual of drivers and give pre-notice alignment of car. So when we design the planting, so the plants should be designed in consideration with operation and maintenance. So we need to choose types, kind of location of trees to avoid tree falling and also to keep safe driving space. So I'd like to introduce unique our company's activities. So we have been restoring natural environment by planting local-oriented trees after growing by ourselves from collected seeds at planned construction site. Because the local seed plants has same gene as local plants around the expressways. So it is effective measure for conservation of regional ecosystem and biodiversity. So operation maintenance is also important activities for green highways. Our company is tackling green recycling. So we have produced compost and wood chips by crushing and fermenting plant waste. In addition, these materials have been used for expressway construction as fertilizer of planted trees. In addition to green recycling, we are also tackling biomass gas power generation to realize more effective use of plant waste. So we have installed this biomass gas power generation system near existing rest area. The system can cover approximately 7% of electricity required for rest area. So that's all for my presentation. So I hope this presentation can contribute Indian road development activities and also waste to wealth and earn carbon credit. So once again, I very appreciate the opportunity of talking to you. Thank you very much, kind attention. Dhanyawad. Thank you very much.
And Shri Gautam Dalmia and Dr. Madhav M.R. Presentation performance evaluation of geocell reinforced granule subbase. Please come.
Just now we heard a presentation by the first speaker in which plantation of trees in large numbers has been advocated, and no doubt trees are good for environment and for our good health and life. But my experience when I was working as chairman of the Accident Prevention Committee showed that at least 20% accidents in India occur because cars traveling at high speed hit the roadside trees. And when a car hits the tree, most of the occupants of the car die. That is the worst kind of accidents. In Mumbai, every alternate day we hear a headline saying that car hitting a tree on Nashik highway, 5 dead, like that. So while planting trees, let us be careful and keep them away from the pavement. Now the next speaker, please.
Compare it with the lab trials which was already done in the IIT Hyderabad, and then so a comparison of that study along with some design approach which was used in the research was presented here. Okay, to start with, uh, I would introduce the the problem, and along with that, I would show the test setup which I've used at IIT Hyderabad for my research, and then testing procedure used, as well as the experimental program, the result, and then I would summarize with my conclusion. And as you all know, the improvement is very mandatory in terms of payments or roads when you compare India, because there are maximum number of there are maybe major roads which are rural, state, as well as national highways, and then this improvement when we have done can go into any of them, which is rural, state, or highways. So most probably it will be a rural is what we would be concentrating on, and it also was extended to a national or state highway as well. And as you are different layers of that payment, and the point is the improvement was done either in both base or sub base when you look at here with the research. And then these are the issues as well, and then there are problems, and then how can we improve them? There are different ways we can improve, like excavating them and some stabilization techniques, as well as geosynthetic reinforcement, which are the recent ones which are which are being used. And there are many types, as you know, which are geogrids, geotextiles, geocells, as well as geomembranes. And then out of which, in our research, what we have used is geocells, which is a honeycombed structure, three-dimensional figure. And then there are advantages when you compare to planar as well as three-dimensional geocells, where it can also hold the lateral confinement, which comes to it, can hold to it, and then it can improve better than the planar geosynthetic, which was used earlier. And in our research, this is the research setup which we have used, and this is customizedly built up using horizontal and vertical movements of the frame, as well as the test tank which was used to simulate the model payment as well as the traffic loadings from the actuator used, which is mounted onto this frame. So this is about 100 kilonewton capacity frame, and this is the hydraulic actuator, and the tank, which is 1 cubic meter, which was used to simulate different payment layers, and was also supported with the various instrumentation methods, like strain gauges, as well as the pressure cells, and also the LVDTs on top of it to look at these surface deformations. And we've used various materials like clay, aggregate, as well as geocell as discussed, and then some part also to look at the performance of the geogrid. Geogrid was also used, and these are the properties of clay as well as aggregate used. And we used the sandy clay type clay, as well as Mart's base grade 3 as the base material for simulating in the experiments. And these are the properties which are used, and the sample was prepared for different using various ways for both clays as well as for base materials also. So for clays, we've used the static compactors with about 5 kg weight, and then we have what is done is a calibration of how much density which is maintained in the lab is always measured, and then using that a calibration curve is measured between the height of fall, number of blows, and then that is simulated in the experiments to find out and maintain the densities as well as the properties of clays as well as the aggregates. So this is a schematic test setup. Usually in the lab, what we have done is we have built a weak subgrade at the bottom using sand or clay, and we've used clay later on. In the research was we started with sand to look at how it behaves, and then we moved on to clay, and then we've simulated that weak subgrade, and then followed by the instrumented at the interface with pressure cells at center, as well as 1 and 2 times the length of the diameter of the plate, loading plate, and then place the geocell on top of it with the strain gauges to see what is the variation of strains with the geocells as well. And once that is placed, then the top is used, is built by the plate vibrator was also used to compact and maintain the densities at the base. And once this is used, we have as showed, the actuator was used on top of it, placing the loading plate, which is circular and with 150 millimeter diameter is what we've used, and the loading was applied from the top, and that was also supported with the LVDT data which was placed at the top, and these are the places where it was placed. And as I showed, this was with instrumentation along geocell with strain gauges as well as pressure cells, which was used in the study. And we also checked for the repeatabilities, and then pretty much almost into the criteria, 95% or 98% was matching to the same things. And then so we made sure the testing apparatus, what we have done is correct, and then we went ahead. And then there are some performance indicators which we have used in this from the data obtained from the cyclic testings and the repeated testings. And so those are cumulative permanent deformations. And as you know, the deformations are elastic and plastic, where all the plastic are taken into account, and then they're accumulated with respect to number of cycles, and that was given as cumulative permanent deformation, and then TBR was also given with respect to number of cycles of reinforced and unreinforced for a particular rut depth. And then this cumulative permanent deformation is the rutting parameter of the payments which is used in the research. And then from there we also computed the modulus improvement factors from the experiments which we have done, and we've got both reinforced and unreinforced modulus of the layers which was simulated, and as you can see, E2 is with only the unreinforced layer, and then even is with the geocell along with the base layer along with the geocell reinforced. So that modulus was computed in different ways by using different approaches like Ishita and Meherov from the elastic solution as well as the Burmester theory, and was also looked at by using the Ken layer methods to find out the E1s and E2. Those are with respect to reinforced and unreinforced modulus, and that is taken into account, and then a modulus improvement factor is proposed using the geocell which was used in the studies. And then we went ahead with the various testings, and then as part of, I would only show some of them which were which can gel towards this, and then the others, because of time constraint, I would be showing only those. And then we can, as you can see, there are tests which were done like with unreinforced and geocell reinforced, and I've also done some with using the surface layer as well. And then and from them, as you can see, these are the parameters which indicated the CPD, that is cumulative permanent deformations, as well as the TBR, and where we could achieve almost 8 was the TBR which was achieved at a settlement range of 5 for geocell reinforced. And towards the paper, if you look at, and then this is what mostly what we have presented in the paper, that is, I wanted to compare it with respect to what it happens with the experiments in the lab as well as the field as well. And these are the pressures obtained, and this is a typical map which shows the pressures, and then these pressures are monitored, as I said, at the interface, that is at the subgrade level, and this is for unreinforced and this is for reinforced. And these are the two tests which we have conducted, 3 different tests which are conducted on Karnataka state highways at Dandeli River Forest, and one is for unreinforced, reinforced, and the other one was conducted only for the subgrade. And if you can see, that is instrumented along with the pressure cells on top of the geocell as well as the unreinforced sessions. And these are the construction procedures which is used, and these are the results which are obtained for only the subgrade unreinforced as well as geocell reinforced using the plate load test which was conducted. And these are the pressures where it almost showed the experimental as well as the field showed similar behavior, and it was almost matching to the extent. And this shows the pressure applied, and with the pressure which is on top of it, on top of the plate load test, and then the other one which is placed at 2 meters away from it. So so these are the pressures measured this is under the plate load, and this is just at about 2 meters from the plate load. And then a design approach was also done, and using those parameters, modulus is calculated, and the modulus improvement factor is also calculated as discussed earlier. And we've given the inputs for various layers